Hello, everybody, and welcome into the growing stage for the Sustainability Roundtable. My name is Ronan Roach, and I'm delighted to welcome in 7 up-and-coming sustainability-related startups to pitch over the next 35 to 40 minutes. Just some housekeeping. So we will have an opportunity for all the attendees to meet with each of the founders of the 7 companies and across the other stages during the expo booth, and also during the networking, which starts at noon Eastern, 9 a.m. Pacific. And if there's any questions throughout, please feel free to ping Cody, Mona, myself, and please feel obliged or welcome to get in touch with each of the co-founders who present today for other biz dev opportunities, co-collaboration opportunities, etc. So I won't bore you with any more details, but I did want to welcome to the stage our first startup founder, Aviran Yakov with ECOPLANT. Yakov, take it away.
Yeah, hey guys, let me share my screen here so you can see a few slides. Very excited to be here. Thanks for the opportunity to present to you our offering, our value proposition. So we are EcoPlant, and we are dramatically reduce CO2 emissions leveraging IoT and machine learning technologies. So and we're going to talk about air compressors today, which considers a fourth utility that you have in any factory: electricity, water, and gas as the first three. And compressors accounts for 30% of the entire energy industrial plants. 90% of the produced products, you have compressors there. Doesn't matter if you have a chips bag or you want to paint the car, you have compressors there. According to the US DOE, 50% of that energy is going to be wasted as a result of leaks and redundancy, overcapacity, poorly timed maintenance, a lot of problems that we see in every industrial plant as a result of incorrect use of air compressors. Our patent-protected technology connect to air compressors, so we communicate with the PLCs, we integrate PLCs of the air compressors. We also take measurements from pipe and sensors, measuring flow, pressure, kilowatts, dew points, all of those measurements that we take from the compressor process. And we optimize that through our cloud-based engine that we aggregate all the data that we take from the factory, and we send back commands. We actually control the air compressors in a way that we reduce energy. We see very good results, and we have good traction with few large accounts. So you see, for example, Coca-Cola site in Michigan. So they are reducing 439 metric tons as a result. For our system, we just closed this partnership with Coca-Cola, so we are very excited to install the system. We already installed in other few factories. For example, this factory in Canal, we see annual reduction of more than 1,500 metric tons in a year. Just imagine this, with this system, with our system, we are cash flow positive. So our business model is a subscription. So we charge annual subscription for the service. We charge less from the energy that we save. It's a fixed price, but it's a cash flow positive. And you see the CO2 reduction, which is significant to a large corporates and companies. It's a very good and I would say large market, $14 billion only in Europe, in the US, when we charge a few tens of thousands of dollars per site that we are subscribed to our service. We already saved the tens of thousands of CO2 metric tons to our customers with more than 1 million kilowatt that we saves. We have partnerships with the DOE, with Amazon, with Techstars. Of course, we are Techstars Illuminating. And also we got from this program great partnership with a company called Ecolab. So Ecolab is a Fortune 500 company that invested on us, also reseller, and they introduce us to their customers. So you saw a few of them, of their accounts at Coca-Cola and Mondelez. And again, we are expanding now to corporates with the potential of hundreds of sites per each one of them. We established the company in 2016 from idea. We ran through IBM accelerator program, and then we met Ecolab and also Cargill, by the way, in Techstars in 2019. We are nominated as one of the top 10 fastest growing IoT firms to watch in 2021, and we are growing, and we have partnerships also with Danone and Hidrom, Nestle, a lot of big corporates. We combine our team expertise with AI and machine learning together with compressed air knowledge. So we have a team that expert in this field, provide insights, actionable insights, help to develop the algorithms of machine learning to air compressors. So just to summarize, we do a continuous monitoring of the air compressor system, provide predictive maintenance algorithms. We dynamically control the system, and this is our IP in our patent. So we continuously improve the system and create automatic pre-alerts. Compared to other products in the market that you want to reduce hundreds of metric tons a year per site, you need to invest hundreds and millions of dollars on CapEx just to get those results. With our solutions, it's a few thousands of dollars subscription, and you get to this result. We have a mission to reduce 1 million metric tons to our customers, and this is ECOPLANT. So I'll be happy to communicate, guys, and this is my email here and phone number. We'll be happy to collaborate with investors and potential customers. Thank you very much.
Ronan, I think you're on mute.
All right, thanks, Aviran. Next up, we have Brian Tsuyoshi Takeda, who will be representing Urchanomics. Brian, let me go full screen for you.
I think I managed to get the screen share up.
Oh, perfect.
Yeah, so maybe if you can allow me to. Does that work?
Yep, Brian, you're all set.
Okay, not switching. I think it's still set on yours, Ronan. Yeah, that's still yours. Oh, you know what? Why don't we just use yours? It works fine. Yes. So, hi everyone. My name is Brian Tsuyoshi Takeda, CEO and founder of Urchanomics. What we do is we are all about kelp ecosystem restoration. Kelp forests are one of the most important ecosystems that we have on the planet, but unfortunately, due to a combination of overfishing, climate change, and pollution, we have allowed the humble sea urchin to explode in population and overgraze them down to lifeless desert-like barrens. If you can switch to the next slide, please. When kelp forests, when urchin populations explode, the kelp forest will eat everything up and essentially collapse it into a desert-like state. The urchins themselves then starve and become empty and have no commercial value for fishers, and predatory species will not eat them. Next, please. And so when you don't have any incentive, whether it's calorific or economic, these urchins will persist and stay on the ocean floor, preventing kelp forests from growing back for decades or centuries if we do not intervene. So what we do at Urchanomics is we specifically target those ecologically destructive urchins, and we rehome them in our proprietary land-based aquaculture systems. Next slide, please. And here we essentially provide them a naturally derived formulated feed, and we convert them from an ecological pest, next please, to one of the world's most premium seafoods, uni. Next, please. In a matter of 3 to 6 months. Oh, sorry, no, 6 to 12 weeks. The ecological restoration is what happens in 3 to 6 months. Essentially, we take those urchins from the ocean floor, convert them to premium seafood in 6 to 12 weeks. When we remove the urchins from the ocean floor, next please, the urchin barrens will then flip back to a kelp forest in a window of about 3 to 6 months. Rona, maybe if you can just click along with the slide deck, I think it might keep the flow going. Yeah. Right. So this is just some images and an example of how an urchin barren state can flip back into a kelp forest. So at day 0, the urchins are there occupying the ocean floor. After removal, approximately about 24 days, next please, you'll see that the kelp will settle onto the ocean floor. And then in about 3.5 months, next slide please, you'll see the kelp forest growing from the ocean floor all the way to the surface. The kelp essentially becomes a habitat for microscopic predators that eat the urchin larvae and prevent them from reproducing and occupying the ocean floor again. They become the food for the little fish become food for the big fish, and we essentially can rebuild a marine ecosystem from the ground up within 3 to 6 months. Next, please. The kelp forests, of course, bind and sequester carbon. Next. The kelp also protects from wave-related erosion as well as ocean acidification. Next. But perhaps most importantly, we're talking about creating meaningful jobs in coastal rural communities around the world. Next, please. And this is probably the most important slide that I'd like to share with everyone. Kelp forests provide ecosystem services, or essentially trying to monetize the value of what an ecosystem provides us as humanity. 1 hectare of that provides ecosystem services that are equivalent to around 29 times that of a tropical forest and 50 times that of a boreal forest. So that is how valuable the kelp forests are relative to other ecosystems that we value so much on our planet. Next, please. Again, our business model is relatively simple. We remove the urchins, we ranch them in our systems, we sell them, and then we donate a percentage of our revenues, or we contribute funds back into the urchin removal and kelp restoration effort, so that we continually have this circular effort that ultimately results in kelp restoration. Next, please. In terms of traction, I see I'm tight for time. Very simply, we have validated our technologies pretty much all around, everywhere around the world. We are already operating commercially in Japan with our factory there. We're building 3 more. We have pilots in Norway, the United States and Canada, which we also plan to scale up. Yes, if I can just get the last slide. Perfect. We are already selling our products at the high-end retailers and seafood stores in Japan, as well as high-end sushi restaurants in Ginza, Tokyo. We also have Michelin star restaurants in Europe serving our European urchins in the market, getting very healthy prices, all while restoring the ecosystems. Yes, thank you. I think that's what I could squeeze in in 5 minutes. Yes, again, thank you very much for the opportunity to present. I hope that we can connect in the various meeting rooms.
Perfect. Thanks so much, Brian. Next up, we have Anastasia Volkova from Regrow. Anastasia,
thank you so much, Ronan. Excellent. And we are going from kelp forest into more food, but now terrestrial. Ronan, can you hear me okay? All good? Screen's up? I presume that's a yes. All right. Hi, everyone. Delighted to be here. Thank you so much for joining. My name is Anastasia Volkova, and I'm the CEO and co-founder of Regrow. At Regrow, our mission is to heal the climate through regenerative agriculture. This is not a secret for anyone that climate change doesn't come just alone by itself. It comes with the pretty dire consequences into food system and to our human population occupying the world. Not only I'm talking about deforestation and desertification, but I am talking about the current food system really creating more problems for humanity as well as the climate itself than solutions. On the other hand, the positive is that we, as industries, governments, society, have realized that we need to reverse the situation and set the net zero goals for 2050, which to make this measurable, quantifiable, and palpable. This is 51 gigatons or billion tons of emissions we're pumping into the atmosphere annually that need to be removed in a scalable, affordable, and globally applicable way. And that's the solution we're seeking. Is there a solution that can not only affect the climate in a positive way, but also help restore the food and agricultural ecosystems, and as a result, bring up the livelihoods of the people, not only consuming that food, but also growing that food. And when we look for solutions and relate them to net zero, of course, we understand that not every solution can entirely solve for net zero. And this particular solution that we're talking about that relates to nature-based carbon removal looks at 20%, which is a very healthy amount of these emissions that we're pumping out, and is scalable, affordable, and globally applicable. Some of you have probably already understood from my introduction as regenerative agriculture mission-driven company that I'm talking about soil, the nature's carbon bank. For those of you who haven't spent a lot of time in the space of regenerative agriculture, the basics are that when we plow the soil and turn it over and establish monocultures, leave the soil fallow, we actually release carbon that was stored in the soil. And there is the opposite process that is possible too. If we switch to regenerative agriculture, if we keep the soil covered, if we implement the practices that lead to sequestration of carbon, we not only can solve for climate change, but with the soil being a huge carbon sink, we can have a profitable business model whereby the farmers that implement regenerative agriculture practices get paid by the corporates, governments, and societies, reaping these ecosystem service value, as Brian was talking about. So what is it that is missing? If we're almost there, if we understood how to treat the soil better, what is missing? What's missing is that if we treat something like a bank, you need to have a system by which you know how much someone puts into the bank, if they ever draw from that account, and who pays into it. And that system of accounting, until recently, scientifically hasn't been possible. It's been recently invented. At Regrow, we deliver an enterprise-grade software as a service solution that does specifically that. It involves measurement of the contributions by the farmer into their soil carbon bank on their specific farm, all remotely using satellite imagery and agronomic modeling and soil modeling. We then keep track of the goals of our corporate customers and government customers, helping them to report on how we're moving towards the emission reduction across either their product lines in consumer packaged goods or more broader government goals. And finally, we enable the verification that truly says, hey, this carbon is still there. You shouldn't be worried about reversal. This payment needs to be made, and we're going to notify if there's ever a reversal event. We are working with the companies across the entire agri-food supply chain and beyond, from farm to fork, so to speak. This is some of the logos of our customers, including titans of food and ag. We also work with foundations that seek to understand and impact the ecosystems in agriculture at a very large scale. For example, we monitor the entire US worth of agricultural land to understand how the farming system is evolving and how we can help the corporate world to invest in it the best way. Regrow is 50 experts. Quarter of us has PhDs in relevant industries. We're currently monitoring over 150 million acres annually, and we're proud to say that our solutions are being used by farmers in more than 45 countries. So not only we drive the corporate impact and governmental impact, but we actually make the change to livelihoods of people on the ground. Have been fortunate enough to be the first agri-tech investment by Microsoft and recently received the investment into our Series A from Cargill. For those of you in the audience who believe that the solution to climate change is not going to wait 10 years, here, soil carbon is what Nobel Prize winner Dr. Ratan Lal calls the most available solution to climate change, and it's readily investable with the right measurement, report, and verification system in mind. Get in touch, and thank you for your attention.
Thanks so much, Anastasia. Okay, so next up we have Arka Ray from the Data Economics Company. So Arka, let me pass it over to you.
Thanks so much, Ronan, and hi, everyone. I'm Arka Ray, Managing Director at the Data Economics Company, and I want to tell you a little bit about our flagship product, the Lydian Engine, and the interesting, complex problems that it is solving for enterprises and consumers by turning their data into valuable, monetizable digital assets. Distributed ledgers or blockchain technology has given rise to a very large market for digital cryptocurrencies and economic tokens derived from them, such as NFTs. However, market-leading DLT platforms have not made significant headway around business applications due to several technical and functional limitations. But despite their limitations in enabling business use cases, blockchain platforms have established a globally accepted market and technical standard for using energy and resources that are spent on maintaining the blockchain network, proof of work, or similar algorithms into digital data tokens that have all the properties of real-world currencies. Given this market background, the founding team at the Data Economics Company asked ourselves a simple but fundamental question. What if we invented a data structure called work chains that could capture the results of energy and resources spent in performing real-world work as digital data, and then turn this inherently valuable data into economic tokens and products that the data owners could transact, monetize, or otherwise use to gain economic value? Over 3 years of research and development, the DECO team has developed the Lydian Engine, which is middleware that uses work chain data structures to transform user data itself into valuable digital assets called Lydian data assets that are stored in something called the user's Lydian vault and can be transacted and monetized over private networks called DNets or data economic networks. Now, as a result, the Lydian Engine enables people and companies to transform any combination of their data sets to valuable digital assets that can be stored and managed through their Lydian vaults. The vault's owner can control exactly who can access their Lydian assets, for what purposes, under what circumstances, and the credit that is due to them for each utilization of a data asset. Now, the Lydian Engine is productized using a middleware model. So for example, DECO's middleware partners in the agriculture sector, such as the Smallholder Farmer Alliance, Accesso, and Terragenesis, have teamed up to build the Smallholder Data Services, or SDS platform, that uses the Lydian Engine as middleware to help their customers, who include major crop buyers such as Timberland, North Face, World Food Group, source crops from smallholder farms from countries such as Haiti, Colombia, Mali, Thailand, Kenya, and many more. Now, a customer such as Timberland wants to source a majority of their agricultural products from smallholder farms within the next decade, while ensuring that all crops sourced meet organic regenerative standards. But then tracking crops like rubber and cotton shipped from thousands of small farms in different countries through a third-party certification process can get very time-consuming and expensive, enough to make bulk purchases from smallholder farms economically unfeasible at scale. But now, with the SDS platform, each smallholder farm is given its own Lydian data vault that collects data directly from the farm and stores them as Lydian data assets representing various positive outcomes, such as the health of the crops, impact on the soil, and long-term environmental impact. The Lydian vaults for each of the farms remains completely in the farm's control and connects with each other to form a network, or a Lydian DNet. And now, Timberland can simply join their own Lydian vault to the appropriate DNet and track every shipment of cotton and rubber back to the specific farm that it came from, in order to prove to independent regulators and even to the public that smallholder crops that they are sourcing are meeting or even exceeding organic regenerative standards. This forms a completely transparent and decentralized self-certification process that reduces the certification costs for a company like Timberland by 10x. And the best part is that the credit for the certification flows directly back to the farmers producing the data. And it's projected to double the yearly income of the average smallholder farm simply by maintaining a single data vault. And this is making data assets literally a new type of monetizable product from their farms. In addition to agricultural traceability, the Lydian engine-driven applications are addressing several high-impact enterprise use cases, such as tracking lead recycling compliance for major battery manufacturers, resulting in measurable reduction of lead pollution, managing dynamic climate and sustainability investment portfolio for Fortune 100 companies, and enabling patient data-driven insights for pharma companies, while reducing the cost of expensive drugs and therapies for patients. The DECO team initially developed its business model and methodology in the health sciences sector, where Lydian engine-based products are targeting a market of 20 billion, with customers that include Fortune 100 pharma and biotech companies. We are happy to discuss these confidentially. And DECO has expanded to form middleware partnerships in the agriculture, core industrials, and climate and sustainability sectors, where Lydian products are targeting a market of over 40 billion, with substantial revenues coming in over the next 3 years. DECO currently has 8 middleware partners taking 10 plus Lydian platforms to market over the next 2 years. And we have about 20 plus enterprise partners who are already on board using Lydian DNets and vaults, and expected to grow pretty rapidly over the next 2 years. We have only scratched the surface of DECO's vision, product strategy, and everything that we are doing with the Lydian engine at the Data Economics company. We will be rolling out a lot more information to our ecosystem as we gear up for our public launch next year. We are looking for some more enterprise partners to partner on existing and new Lydian products, as well as enterprise developers and hobbyist developers to check out the Lydian SDK build that we will be rolling out early next year. And of course,
Arco will have to save the rest for the expo booth.
Actually, I'm done. So I just wanted to say we're always looking for engineers and scientists. So if you are interested in what we talked about, please come by the expo booth. Thanks so much, Roland. I appreciate it.
Perfect timing. Thanks so much, Arca. All righty. Next up, we have Amir Shiner. Let's see, Amir. Adding you up here. And Amir is with RepAir DAC Limited. So Amir, I'll let you take it from here.
Sure. Hello, everyone. My name is Amir Shiner, CEO of RepAir. And what we are doing is we have a novel approach to direct air capture aimed at playing eventually a key role in restoring the global CO2 balance. Now, there's no question anymore that direct air capture has to be an essential element in an array of solutions in order to meet the IPCC targets and to really mitigate the effects of the climate crisis. Now, the main challenge with direct air capture, rather than a technological challenge, the main challenge is the economies of scale. You know, a solution, a viable solution of direct air capture has to provide a solution that will be at less than $100 per ton of CO2 captured, has to be highly scalable, to be deployed in numerous sites and in very large scale, reaching gigaton scale in 10 to 20 years from now. What we provide is a scalable solution for direct air capture that is based on an innovative electrochemical cell-based technology that is inspired in its design by alkaline exchange membrane fuel cells on one hand and nickel cadmium battery on the other hand. It's kind of a hybrid inspiration in the design with a relatively straightforward principle of operation. We stream air into the cathode side of the cell. CO2 immediately binds to hydroxide ions produced by the cathode to generate bicarbonate and carbonate ions. Then CO2 depleted air immediately flows out back to the atmosphere, while the bicarbonate carbonate ions are transported through a highly selective exchange membrane to the other side of the cell, where a reverse process takes place. CO2 is consumed, hydroxide is consumed by the anode, and CO2, pure CO2, is pushed out or out of the cell for either long-term storage or utilization for products, depending on the application. And this technology has several great advantages. This is a truly continuous separation process that is completely electrically driven. The energy is typically produced by renewable sources. The whole process is it takes place at ambient conditions. This allows us to use lower cost materials for the cell structure, and it is modular and highly scalable. Large number of such cells are stacked and operated simultaneously to reach the required capacities, eventually huge capacities that will be required in order to make a meaningful effect on the environment. Our proof of concept shows, first of all, the technology works. We managed to, using the electrochemical cell, to take the CO2 out of the air and move it to the other side of the cell and separate it effectively. Not only that, but that the energy consumption of the process is really low. We're talking about 650 kilowatt hour per 1 ton of CO2, which makes it really interesting with a scalability potential. It's really interesting and promising. And when we compare our results in terms of energy consumptions to the other alternative direct capture approaches, we are the right hand columns in blue, before and after optimization. We can see that it is very attractive in terms of energy consumption. In terms of our status, we just finished the seed financing round of $1.5 million. And this is secured, and this will allow us to really accelerate our R&D activities, recruit additional staff, and really push forward with ambitious plans. In parallel, we're now exploring additional funding from various R&D grants. We are now collaborating with DLR from Germany on a Horizon Europe R&D call for the development of direct atmospheric carbon capture and conversion. And we registered for the X Prize competition. It's coming up early next year. We are a team of highly experienced scientists, engineers, managers, entrepreneurs with background in electrochemical cell development and commercialization. And we're now, as I said, expanding this core team and recruiting more people, and would be happy to meet you at our booth and answer any other questions and more questions that you might have, and connect to you. Thanks very much for the opportunity to be here.
Awesome, Amir, right on time. So next up, we have Laura Rodriguez from Rated Power. So Laura, let me put you up on stage.
Hello, everyone. Thank you, Ronan.
Alrighty, take it away.
Okay. I don't know if you can see my screen yet. Okay, I think so. So did you know that solar energy is the fastest growing energy source on the planet? And do you know what it actually takes to build a solar plant? Well, we know, because we used to do it. Hi, everyone. I'm Laura Rodriguez, and I'm Business Development Manager at Rated Power. I'm thrilled to be here today to be able to share our story with you guys. Our 3 co-founders worked for several years developing solar plants all over the world. To get just one project done, they could spend weeks, even months, calculating formulas and algorithms and generating hundreds and hundreds of pages of engineering documentation. So one day they thought, could this whole process be streamlined? Well, it could, and so we did. we developed a comprehensive software package that, by scanning millions of iterations, instantly optimizes the plant design and automatically generates more than 300 pages of engineering documentation. We transform 6 weeks of engineering into 2 minutes. This decreases the cost of energy generated by 5%, which directly translates in 20% higher profitability. So how does it work? Well, this is our software, PV Design, and it's very easy to use. Basically, our clients just have to upload the project location, select the main equipment and criteria, and finally, in just a few minutes, they can see and download all the documentation. Our customers are all the different players in the solar industry. We cover the whole value chain. Today, they're mainly solar developers, contractors, engineering companies, equipment manufacturers, and even banks and funds. All this equates to a $5 billion market opportunity. To date, there is no global software to fully carry out the design and engineering process as we do. Our competitors are other tools that automate specific parts of the solar design. Our business model is a software as a service based on annual subscriptions, and we do offer a 14-day free trial before purchasing. Now let's talk about our amazing team. We're based in Spain, a world's hub for solar energy. We strongly promote meritocracy, diversity, and equality for growth and equality. This has led us to become a multidisciplinary team of over 40 people from more than 10 nationalities, where half of them are women. Our founders, Juan, Andrea, and Miguel Angel, have been working in the industry together for 10 years already. And during the last few years, we've received big awards. Among others, we were selected by Techstars, therefore are participating here today, the Elemental Accelerator Program, also in the US, and the H2020 European Commission grant, which meant almost 2 million euros to develop our product. In 4 years, we have launched our product, simulated over 2,000 gigawatts, which we like to say equals to more than 500 years of work of traditional engineering company, and we already have over 80 paying customers. Some of them top-tier companies like AIS, Iberdrola, or Conedison. But this is not it. We already have over 3,000 users working with PV design in more than 150 countries, from Chile to China, the States to Australia. And of course, by being a global company, this has allowed us to study each market individually to be able to adapt and provide a leading software solution that is always innovating. Now let's talk about our future. We reached break-even 4 months after founding the company, and even though we were already cash flow positive, we want to become the standard in an industry that is doubling its size every 2 years. And this is just the beginning. We believe in a future, the same future that our customers believe in, which is not just solar. It is about providing accessible green energy worldwide, mixing solar, wind, and storage in integrated systems. This is where we're headed, and we have the right technology to do it. Let's bring cleaner, cheaper, and better energy to everyone. The energy of the future needs the engineering of the future. It needs PV design. Thank you, everyone.
Awesome, Laura. Right on time. All righty. Well, last but certainly not least, I'm going to bring up Alison Dring from Made of Air. Alison.
Ronan. Hello, everybody.
Hey.
Great. Second. Is that clear? Well, hello, everyone. I'm Alison Dring. I'm the CEO and the co-founder of Made of Air. I want you to think a little bit about the room around you and the chair maybe that you're sitting in. A lot of the products around you are made with fossil resources that have very high CO2 emissions. In fact, most manufactured goods around us are made from fossil resources and with high embodied carbon. In fact, if you think about it, materials are this systemic problem that have a lot to do with how we source our resources. Our resources are currently coming from underground in the form of mined materials or in the form of fossil resources. And right now they're accounting for 27% of our global emissions. And you would think that with climate change and with sustainability being on the rise, that we would be minimizing our production in response. But actually, our population is about to increase in a big way. And in order to accommodate for the housing and the products and the infrastructure for this population increase alone, we're going to see material demand go up, and we're going to see those emissions attached to materials more than double by 2050. So let's talk about plastics. Durable plastics, unlike disposables, don't have biodegradable solutions. And a lot of these manufacturers working in durable products are reliant still on fossil resources and don't have many alternatives. It's clear that industries have to be able to cut the cord to fossil resources in this sector. But if our population is increasing and our demand for stuff is still going up, where are these resources going to come from? So Made-of-Air is looking at things differently. What we have is a climate crisis that is systemically a problem due to an oversupply of CO2 in the atmosphere. So if you think about it, climate change is actually a material problem. The CO2 is actually carbon. And at Made-of-Air, we're thinking about this as our biggest challenge, our biggest existential threat. And we're asking, can we turn it into our biggest resource? So Made-of-Air has produced a renewable, durable thermoplastic compound that turns products into carbon sinks. This is a negative emissions technology. It's a carbon negative material. And all that means is we're taking more CO2 out of the air than we emit in making it. It's a carbon storing thermoplastic compound, which means that products that manufacturers make with this raw material will become engineered carbon sinks. And its aim is to be drop-in ready to work with existing production processes, just like compression molding or injection molding or extrusion, as much as any other material. So I want to share with you why this is such a radical idea. My co-founder and I have worked a long time in the building product sector. And our product was an environmentally friendly one. It was a facade panel, and it could reduce air pollution in cities. And it was made of plastic. Recycled plastics don't work for most building applications. And there wasn't a way to make our kind of environmentally great product without harming the planet. And there's an enormous amount of materials going into buildings relatively unchecked. So if we just go a little further with this, imagine if all of that material could be better than carbon neutral. Think about all the sustainability targets that we all have, our corporations, our global targets to be carbon neutral. Imagine if our manufactured goods could reverse climate change just by being made. I firmly believe we can do better than carbon neutral, but we need carbon negative materials to do it. So how do you make a carbon negative material? So we're starting with wood waste. And this is a form of biomass, and like any biomass, it photosynthesizes in its lifetime. It's absorbing CO2. But when that plant material starts to decay or decompose, you'll see the CO2 return to the atmosphere. And so what we're doing is interrupting that natural cycle. We're collecting these waste streams, and we're converting them into biochar. And in that step, we're permanently locking the CO2 into a form of elemental carbon. We are then refining the chars through a series of processes where we end with a useful thermoplastic granule that we can sell into manufacturing lines to create carbon sinks in products. So the impact here is direct. For every ton of material that we produce, we're taking 2 tons of CO2 from the air. This isn't like an offset. I think I would just make that clear. We're not talking about emissions reduction or step change. What this implies is actual climate change reversal. We're selling in 2 ways. We sell the raw material straight to manufacturers, OEMs, tier 1s that can produce products that they're already making or create new products based on the material. We're also doing a bit of in-house forming. We do that with partners. And we're aiming it at 3 key industries that are operating in the durable goods markets. We're looking at consumer goods with a focus on furniture. We're also looking at the automotive sector and the wider mobility sector. And we're also, which is closer to my heart, in the built environment, where we can not only replace plastics, and I think in automotive and furniture, we're doing a lot of plastic replacement, one-to-one studies on those materials. When we head into the built environment, it's a much more hybridized space, and we're able to take on some of the mined materials that have much higher CO2 emissions, like aluminum paneling or high-pressure laminates or cement fiber boards or these sorts of cladding materials and paneling non-structural materials that you see in buildings. So we kicked off a couple of partnerships already. We're working with H&M late last year to produce this pair of sunglasses that you see. This is the world's first ever carbon storing pair of sunglasses. Sunglasses aren't our key target market, but it's something that we worked quite well with H&M with, and we're now starting to explore multiple applications across their supply chain. It's also very typical customer scenario where we're starting to look at wider supply chains and how we can deal with Scope 3 emissions for some of these larger consumer brands. We've also worked for over 2 years with Audi to convert the material into facade panels. You can see here, this is the first of many dealerships that these panels will be distributed worldwide. So we've been engaged in 3 active pilots. We're also working with the US furniture customer to create a carbon negative chair. And we're working with more than 7 consumer brands on various applications, but with all kind of the same motivation in mind, which is to help them reach their carbon neutral targets and to help with their supply chains in dealing with Scope 3 emissions.
Alison, I'll have to cut you off there, unfortunately, but definitely
Okay.
more to come during the expo and networking session. So
Sure.
with that, I'd love to thank all 7 founders for joining us today. I know there's plenty more to come, but anyone in attendance to the growing stage, I'd ask that you please revert back over to the main stage for a quick debrief by Cody and Mona. And we should be kicking off the expo and networking sessions in just a few short minutes. So with that, thanks again, guys. Really appreciate your time, and best of luck.